Hello, in this video we are going to learn about the building of the 1D study flow model in the HEC RAS. Okay, so first we need to create a file. Okay, so for that, so let's move to I have opened the HEC RAS 6.4.1 and this is its user interface. Okay, so here you need to go to file and create the new project. Okay, so new project is name the location, so name this location. Okay, so this is my folder path. Okay, we'll name this as 1D model. Okay, and the unit system will be in the SI. Okay, so I have defined the name of the project. Okay, now we need to add this terrain topography, and we need to create the river geometry. Okay, so for that I am moving into RAS mapper. Okay, this is the RAS mapper, so I'll open it. So here you can see this is the main window of the RAS mapper. Okay, so here I need to define the projections. Okay, this is the projection system of that location. Okay, I'll go to the same folder where I saved this file. Okay, so here I have this projection file. Okay, so the projection file is nothing but the UTM coordinate zone of that location. Okay, apply. Okay, so here I have defined my projection. Still I can't see the any changes because it's I have not added the terrain. Okay, so I will add the terrain from here. So in the ribbon you can see this terrain. Okay, terrain. Okay, so now add this terrain. Okay, so same folder where I saved this file. Okay, so this is the terrain file. Okay, I will add that terrain data. Okay, so here I will create the terrain from this the DEM file. Okay, so it will create the surface in tin format, that is triangulated network format. Okay, I will create it, so it will take some time to load and create that 3D surface. Okay, so now you can see the 3D the topography is visible in the RAS window. Okay, so here you can see this is the alignment of the river network. Okay, so here to run the study flow model, so I will consider a small section of the creek, or you can say I will consider a small zone to build the 1D steady state model. Okay, so I will select this part. Okay, I will select this part for my to build a sample 1D model. Okay, and in the meantime, if I want to add the uh, the the Google Earth background imagery, I can add it from here. So here you can see on my left here there is a map layer. So check the map layer, right click and add web imageries. Okay, so in the add web imageries, I will select this Google satellite. Okay, and I'll give okay. So here the Google Earth image will be coming as a background. Okay, so if you want to make the little transparent so that you can see the uh, background terrain, you can do it from here. So you can reduce its visibility. Okay, so now you can clearly see the actual river topography and the and its terrain. Okay, so now I will create the geometry, this river geometry. Okay, in the geometries, right click and create a new geometry. Okay, here I will give the name as 1D model. Okay, and I'll start editing this 1D model layer. So here I'll need to create the river. Okay, so here I will select this river. So once you select the river, you can see a pencil command which is coming here, so it is indicating that now I can add the feature. Okay, the icon right next to is if I want to edit any features, so I want to change the alignment or I slightly remodify the alignment, so I can use this edit features. Okay, it's same as what we do in the GIS. Okay, so here I need to create my river network first. Okay, so here I will create the river network. Okay, so here you can see this is the Talweg zone. Okay, this is my Talweg zone of the creek. Okay, so I'll start drawing my drawing my network. Okay, from upstream to downstream. One thing, it's whenever you create a HEC RAS geometry, river should be drawn from upstream to downstream. Okay, so since I know that it is, you can clearly observe from the drainage network. So these two streams are merging here at this confluence point, and later it is flowing toward the downstream. So that means this is the upstream and this is the downstream. Okay, so always draw the line stream the river line from upstream to downstream. Okay, so I'll start clicking on the lines and network will be created. Okay, I'll start clicking. I'm using my left mouse, okay, to click the network, to draw the river network. Okay, so here you can see wherever I'm seeing this the depression line of the stream, I am drawing the over which I am laying my river center line. Okay, okay, so here I'm wanting to end my network. So here, that's why I have double clicked my left mouse. Okay, so the river name, I will name the river name as creek. Okay, the reach name 1. So I have drawn my river network. Now I will create the left bank and the right bank. Okay, so left bank is always the left towards the direction of the flow, so the direction of the towards the direction of the flow is towards my right. Okay, so this is the direction of the flow. This is the upstream to downstream. So this is moving from my left side to the right side. Okay, so here this would be my left bank and this would be my right bank. So always draw the bank line from left to right. So first draw the left and later draw right. Okay, so this is my left bank and this is my right bank. Okay, so I'm drawing my left bank first. Okay, so wherever I can see the the banks of the river, I'm drawing on the banks of the river. Okay, so here you can see wherever I'm seeing the banks of the river, over which I'm drawing my bank, I'm defining my bank line. This is the left side and I need to draw for the right side bank. Okay, just drawing it. So here this is time to end. Okay, so whenever I want to end this bank line, I'll double click on it. Okay, so I defined the left bank. Now I time to define the right bank. So right bank I am defining the okay. So now time to draw the flow paths. Okay, so flow paths, I need to draw my flow paths. Okay, so this is the flow path. I need to define the flow path. Same, left side first and thereafter right side. So as the stream ends, so I need to stop my left bank, left side overflow path. Okay, same on the right side. I need to create the flow path. Okay, so now time to create the cross section. So draw the cross section always from left bank to the right bank. Okay, so this is the left side and this is the right side. Okay, so I'll create the cross sections. So this is my first cross section, so second cross section, my third cross section, fourth cross section, I will create some more intermediate cross section. Okay, so I have created some cross sections from upstream to downstream. So I have completed the river network with all the cross sections and the flow path line. Okay, now I want to save this. So for that I need to stop my edits and I want to save whatever the geometries which I created in the RAS mapper. Okay, now I will save here in the file, save it, and I will move to this I will move to this the main page of the HEC RAS 6.4. Here I will move to the this view geometry data, view or edit geometry data. Okay, so here then I will add I will import this this RAS geometry to the HEC RAS geometry. Here, file, open. So this geometry which I created here will be coming here and I will open it. Okay, so here you can see this is the HEC RAS 1D geometry. Okay, so now I have created the 1D cross section with topography. Now I need to create now I need to assign the Manning's roughness table. Okay, for all the cross sections. So for that I need to move to this table and select on the Manning's value. Okay, so first I need to assign for the left bank. Okay, so left bank I will name the left bank as some assume that it's mostly the agriculture land use, and I will assign the Manning's roughness as 0.05, assuming the short grass land use pattern. Okay, for the left bank, and assume same for the right bank. Okay, right over bank. So same I will assume for the right over bank. So that's why I'll copy and paste the same value. And now for the channel, this is the main channel, I'll assume this Manning's roughness coefficient as 0.035. So I'm assuming the condition that the clean water is flowing through the river and the bed is covered with gravel stone. Okay, that's why I'm assuming the 0.035 Manning's roughness throughout the alignment of the stream. Okay, so I'll copy this 0.035 Manning's roughness for the stream, that's for the main channel zone. Okay, so here I have defined these Manning's roughness for the cross section. Okay, so I'll show you how the cross section looks. Okay, so this is the cross section of that creek. Okay, so this is the stations. Okay, this is the horizontal stations and its vertical elevation with respect to a reference elevation or the mean sea elevation. Okay, and here this is the length of the leftover bank. So this is nothing but the distance from this particular cross section to the downstream cross section. What is the length? So this is the length of the leftover bank and this is the channel. So what is the distance from this point cross length between this point of the channel to the next downstream cross section? Okay, and same for the right over bank. and this is the bank points. So these are the bank points, you can see this is the bank points. Okay, this 558.4 and on the left side, and 597.1 is the right side. Okay, and this is the contraction and the expansion coefficient for the cross section to cross section. So it will be remain same for the cross section. If they have any sudden contraction in the cross section, so then we need to change this contraction and expansion. So that we will look into in the when we are working out on the bridge model and the culvert model. Okay, this contraction and expansion parameter. Okay, so here we have defined the geometry of the creek. Okay, so I will save this geometry which I have created here. Okay, file, save the reverse geometry. Okay, so I have created my geometry and I saved it. Okay, so now move to the now time to create the study flow data. Okay, so to create study flow data, I'll close this geometry data, so since it is completed. Okay, now here I will move to the edit study flow data. Okay, so this is my upstream. Okay, so this is the upstream section, so 5574. so here I will assign the flow. Okay, this PF is nothing but the flow profile condition. Okay, so flow profile condition, I will assign the flow as 5000. Okay, 5000 no, fine, yes, I'll consider 3000 Qmax of the flow. Okay, on this extreme upstream section where the creek our the river model starts. Okay, apply, and I'll save this study flow condition as std flow. I'll name this as std flow. Okay, now I need to assign the boundary conditions. Okay, so in the boundary conditions, what I can assign for this arrangement of the river, so there is no drop structures on the upstream, so that's why I can't consider this critical depth on the upstream. Okay, and there is no other known elevation which is available on the upstream, so it's ungauged river. So the option left is the assigning the normal depth condition on the downstream. Okay, so 591 sections. At the 597 the sections, we need to consider the bed slope, so which makes assumption that flow is passing through steady uniform flow at this downstream section. So for that we need to consider the bed slope of the cross section. Okay, so to do that we need to measure that from this river profile. So to do that I will move to this one, view profile. Okay, I will consider the average slope of this last two cross section. Okay, so to measure the bed slope I can use the tool control. So once you get to use the tool control, press the control button, so you'll get the icon like this, the scale icon. So I'll click on the one side of the point of the cross section and drag it to the another side. Okay, so I'll get approximate the slope of the river bed is 0.047. Okay, similarly for the next cross section I'll do the same. Hold the control and click on the another point on the cross section, so along the bed, so I will get the bed slope. This is dy by dx, so I will get the bed slope between last two cross sections, so that will be the average bed slope, so that will be my normal depth condition on the downstream. So average, So this is my average bed slope, this is 0.01. okay, I'll copy that and paste it here in the boundary condition. This is normal depth boundary condition, paste it here, okay, and apply. Okay, so we have created the geometry and we have assigned the Manning's roughness coefficient. It's nothing but we have assigned a hydraulic parameter to the cross sections, and we have defined our flow condition and the boundary conditions at upstream and downstream. Okay, so now I will save this study flow condition. Okay, close this and close the profile. Now I will run the 1D model for steady state. Okay, so run study flow analysis and I will save this plan, new plan, 1D study state, 1D study state. Okay, fine, now we have defined it. 1D std. Okay, so now I'll give the compute. So the model is run, the simulation is completed. Okay, now I will once again move to the RAS mapper to observe the results. Okay,